Hello, welcome to this lecture video. I am Teacher Melay, and our objective for today's video is to talk about or to use Kolmogorov Smirnov test to test normality of the data. In the previous videos, we were able to discuss the importance of knowing the normality of the data, because of course this is one of the requirements that we need to satisfy before we can use mean, in just in case you are trying to figure out what measure is applicable or the most appropriate for your data. Because if you can still recall, when we are talking about the appropriate measures of central tendency, we have two conditions. The first one is that we must know what is the type of our data. Is it nominal, ordinal, interval, or ratio? And just in case it is at this interval or it is interval or ratio, we need to check whether our data is normally distributed or not. In other lessons, in inferential statistics, for instance, we again need to know whether the data is normally distributed or not, because of course this is also our initial assessment before we can determine if it is appropriate for the test that we are going to use, because we actually have parametric tests and non-parametric tests in inferential stat. And all data that is normally distributed, or the data that are normally distributed, can only use the parametric test. Okay, so in the previous videos, we were also done with some of the steps or some of the procedures that you can be used, particularly descriptive statistics method of determining the normality of the data or the shape of the data, whether it is normal or skewed. So the first one presented to you is you can actually use histogram, you can use backsplat, you can also use the other methods like comparing the computations in the measures of central tendency. You can also use skewness and kurtosis. But the problem with the use of descriptive statistics is that what if, how sure are you, for instance, that the data is approximately equal for measures of central tendency? Or what if, in case that in constructing your histogram, it is it appears like normal, but the data is not normal because of the use, for example, of the intervals in your graph and all other factors that might influence you in making decision whether the data looks normal or not. So in this video, we are going to consider an inferential method in determining whether our data is normally distributed or not. So this is if just in case we cannot use the central limit theorem. So for a review again, so we do not need to check for the normality if the number of a sample size, or if rather the sample size is at least 30, because by central limit theorem, this is sufficiently large enough and it approaches to normal. And if your problem is that you have grouping variables, then it means that it must also be equivalent. So just like, for instance, if the number of respondent is 60, so it means that if the grouping variable now is set, so you have 30 male and 30 female. So you also need to consider that before claiming that the data is normally distributed by central limit theorem. Okay, so let's go back to our main concern, the use of the Kolmogorov-Smirnov test. So we will use Kolmogorov-Smirnov test to our two data here, the data on life satisfaction and the data on psychological well-being. So if you watch other videos, so you are familiar with the two data that we are talking about. So let us open PSPP and generate the Kolmogorov-Smirnov test to determine the normality of the data. So this is our PSPP. So we will just open our data. It's already here. File open. So it is, let's start with life satisfaction and then just click, oops, file open. Let's repeat the procedure. I failed to click open. Okay. So if we will check, for example, if the responses in item 1, item 5, and the mean are normally distributed, so we will use, so kindly take note of the procedure. Kindly check analyzed and then locate non-parametric test. So Kolmogorov-Smirnov test is a non-parametric test. So this method of checking if our data is normally distributed or not is for the whole group or for one group only. So non-parametric and then click one sample KS. So let us locate so item 1, 2, 3, 4, 5, 6, and mean. So all the values that we placed here, or rather the variables are items 1 to items 5 and the mean. But of course, our concern is the mean. So click normal and click OK. So actually, we do not need to check for the normality because as claimed when we analyze the data, there is no need because the data is normally distributed because of the number of sample or the sample size because the sample size is 120. So this is now the result. So let us copy this so that it would be easier to see. So I will just copy this in a separate file. Let's use documents. Okay. So as you can see here, so the values, so these are the values of the Kolmogorov-Smirnov, the z-test, 2.15, 1.72, 1.80, 1.52, 1.94, and 1.27. And given the asymptotic significance or the p-value, so we have the following p-value. So how will we know if the data is normally distributed or not? Actually, the null hypothesis here, or our HO, is the data is normally distributed. So this is our null hypothesis. And for us to determine whether we will reject or accept this null hypothesis, if P is equal to, if P is less than 0.05, we reject the null hypothesis. which means that the data is not normally distributed because we are rejecting the null. So if it is greater than, we are accepting the null hypothesis. So let us consider. So the p-value for item 1 is 0.000. It is less than 0.05, so reject HO. P is 0.003, item 2. This is again less than 0.5, reject HO. P is equal to 0.002, reject HO. P is equal to 0.012, again, reject HO. P is equal to 0.001, reject HO. P is equal to, so we have 0.63. So this is the value. So we are actually copying the value here. So this one. So 0.063. 0.063 is greater than 0.05. So which means we accept HO. Therefore, the mean is normally distributed. So the mean is normally distributed. Item 1 to item 5, items 1 to items 5 are not in item 5 are not normally distributed because we are rejecting HO. So we only accept HO here for the mean. So that is for our data on life level of life satisfaction. Let's move to another example. Let us also consider psychological well-being data. So file, open, psychological well-being, click open. So we will also consider to analyze non-parametric test, one sample KS. So let us get all these items. So except the level, we will not get the level anymore. Then do not forget to tick normal and click OK. So let us see. And let's copy this. So I am using a sniping tool because as mentioned before, we cannot copy because we are using PSPP. So you can let us consider example number 2. So these are the values. So by looking at the value, if it is greater than or less than 0.05, so is identified here. Like for example, item 1, it is 0.019, it is less than 0.05. We are again rejecting HO. For item 2, we reject HO. Item 3, we are rejecting HO. It is 0.034. Item 4, we accept HO. Item 5, accept HO. Item 6, accept HO. Item 7, 0.215, accept HO. Item 8, accept. Item 9, accept. 10, accept. 11, reject. 12, accept. 13, reject. 14, accept. And the mean, accept. So if we are going to, again, just in case that the data is less than 30, we have to check for the normality. Or if, for instance, it is not equivalent, like for, again, example, for male and female, it is more than 30. However, like say we have 60 boys or male, and then only 15 females, there is again a need for you to check because it is not equivalent. So the number of sample for each group, so it's not equivalent, you need to check for the normality. So just to summarize, we reject HO. We reject HO for item 1, 2, item 1, item 2. So let us place that. So we are rejecting HO for item 1, 2, 3, reject item 11, item 13. And we accept HO, which means that the data is normal for item 2, item 4, 5, 6, 7, 8, 9, 10, 12, 14, and okay, so this is how to generate and to determine whether the data is normally distributed using one sample Kolmogorov Smirnov test. Thank you for listening.